Thank you, Rohin. Great to speak to you all. So I wanted to talk to you today about a topic that's a bit of a passion of mine, which is the application of AI in mining. And it's not really a new topic. I guess we've been trying as an industry to make use of this technology for some years now, probably getting close to a decade. And I imagine most of you have had at least one or more experiences with a project that didn't go so well. And I wanted to today explore some of the reasons why projects don't go so well and effectively what we need to do about it as an industry to get more out of this technology. But to do that, I wanted to start out by asking you a seemingly unrelated question, which is, this thing doesn't seem to want to advance. Okay, hopefully I didn't push it too many times there. Okay, so what do ice cream sales and shark attacks have in common? It turns out quite a lot. This button's not working. It's all right. One moment. I think we're a little bit too soon to promise no technical issues, but we will fix this momentarily. Happy days. There we go. So, I mean, here we see a data set of monthly ice cream sales and shark attacks plotted on an XY scatter chart. So you can see that, if you gave that data set to a machine learning algorithm, it would learn to make predictions of shark attacks on the basis of ice cream sales. And it would do this with actually quite good accuracy. And you can imagine a well-meaning data scientist inventing a narrative to say something like, well, maybe when people eat ice cream, their blood sugar levels peak and then this attracts the sharks or some such nonsense. I guess one thing I've learned along my career is that any data scientist worth their salt is able to construct a narrative to explain any model output. But what you've probably all realized by now is what's actually going on here is this. This is a northern hemisphere data set. And you can see that really there's a latent variable here, which is the temperature. And on hot days, people are more likely to buy ice cream. They're also more likely to enter the environment of the sharks and encounter them in a negative way. Now, I guess, this is a simple little toy example, but the key takeaway here is the realization that a lot of the information we needed to understand this system does not exist in the data set. And unless we understand the causality behind the creation of that data set, we often run the risk of concluding incorrect things or making incorrect conclusions and recommendations that don't hold water. So how does this apply to mining? Well, hopefully for every project that you've been involved in that may have had some difficulties, you've also had some successes. And we've seen a number of successes in this space. Capital efficiency can be increased substantially through the use of things like simulation modeling. Throughput can be increased by the use of algorithms at bottlenecks like SAGs, etc. And my personal favorite is the application of this technology for recovery, which is obviously particularly relevant for copper. I know most of you on the line will be more than familiar with the process of recovering copper from ore, but for those of you that aren't, just a quick 101. What we have at any copper production process is effectively a beneficiation step where we're trying to extract the value-adding metal, in this case the copper, from the non-valuable metal, which is the waste. We're trying to get that metal into the concentrate. And the reason that this is such an important step in the value chain is because it's where a lot of value is created or destroyed. We either put those metal atoms into the concentrate and we get paid for it, or we put the atoms into the waste. And we've already paid to dig them up, and we're effectively just putting them into the tailings, which is obviously not great if we're trying to make the most of our limited resources. Now, there are two things that we care about when we're trying to optimize this process. The first is recovery. That's the percentage of the copper that ends up in the concentrate. How well we're doing our job. How well are we extracting the maximum amount of value from our ore body. The second is the copper concentrate grade, so the grade of our con grade. And you can see that there's a natural trade-off here because the easiest way to get 100% recovery is to do no concentration. Now, this is done generally in a set of flotation cells that looks something like this. If you walk on top of these and look down, you'll see bubbles being blown into a slurry. What happens is we add a reagent to the slurry here, which causes the metal to become hydrophobic. It attaches to the bubbles, and we skim the metal off the bubbles at the top. So, sort of around about 5 or 6 years ago, people started to think, well, maybe we can use this newfangled AI technology to improve this process, to increase our recovery. And to understand a bit about kind of how this has been applied, I want to take you back to where it all started, where we've seen tremendous value created from the application of AI, and that's in B2C businesses. So a brief digression. I want to tell you a little bit about Starbucks. Starbucks were one of the first businesses that took advantage of this technology, and they used this technology to optimize marketing and sales. And as I travel around the world, I like to go to Starbucks quite a lot because unlike mining, they don't have a great deal of variability in their production at all. You know exactly when you go to Starbucks, you're going to get exactly the same as what you got the last time you went there. I also like to take photographs of the various ways in which they managed to butcher my name. So they decided several years ago that they wanted to embark on what we call hyper-personalization. So the idea is this: you have a chap comes into a store, he's asking for a coffee. You know a few things about him, his age, his purchase history, etc. And you might ask them, would you like to buy a muffin? And he would say no. And then, would you like to buy a donut? He might say no. And by the time you ask him, would you like a croissant? He's already left the store. So the idea behind machine learning or AI is to effectively build a digital replica of this customer. And with this digital replica, you can effectively ask all of those questions in parallel, and then you can just offer the product that the customer is most likely to purchase. Now, there's one key realization I want you to make from this. The decision and the value are both dependent on the outputs of the model. That is to say, I only really care about how accurate the predictions are. I don't care so much about how those predictions are made. Now, let's contrast that against when we apply this same technique to something like a flotation circuit. So here's our real flotation circuit. It's characterized by things like the kind of ore type that's coming in, the mineralogy, the reagent dose, the concentrate grade target that we discussed a moment ago. And the key output that we care about, as discussed, is the recovery. What percentage of the metal that I've already paid to dig up am I going to be able to sell? So we use our newfangled fancy AI to build a digital replica or a model of that system, and we feed in all of the inputs to characterize it, and we get some prediction of recovery. Now, if we think about what are we actually trying to do here, we realize that in this case, as distinct from the previous one, the decision and the value are on opposite sides of the model. That is to say, whereas before, in a consumer-facing business where I'm really reliant on the accuracy of my predictions and that's all, in this case, I really care about how that prediction is made. My model better understand the link between something like concentrate grade and recovery, or it'll come up with incorrect recommendations. I mean, this is precisely analogous to the ice cream shark attack example that I showed you earlier on, just slightly more complex. And here's the problem, in reality, right? This is a data set which is sanitized from one of my clients' flotation circuits, and you can see effectively a scatter plot of recovery on the y-axis and concentrate grade on the x-axis. And if you just gave this data set to a well-meaning data scientist, they would train an algorithm, and the algorithm would learn what the blue line is showing you there, which is essentially saying that, oh, look, I've found out a way to get huge amounts of value for you. All you have to do is increase your concentrate grade, and it'll increase your recovery. Now, if you walk in and present this result, to a team of metallurgists, they'll immediately tell you to get out of their office, because this is about as convincing as walking on down the street and telling a layperson that gravity goes upwards. We just know that this isn't the case. All we're really seeing in this data set is that on days when things are good, they're pretty good. So on days in which we recover most of the metal, we also see more metal in the concentrate grade. This is not a causal relationship, certainly not the causal relationship we care about. We actually know from first principles that all else equal, the actual relationship has to look like the dashed red line. So how do we overcome this? I think one of the things we've learned sort of through various failures leading to successes is you can't use a lot of the AI techniques that are totally non-parametric. You need to use not just what's in the data, coupled with some an algorithm like a random forest or any sort of non-parametric method like a neural network. You need to somehow find a way to impose what you know to be true from the laws of physics. And this is a good thing, because I don't need to relearn the law of conservation of mass. I'm pretty sure that if I put an extra ton of slurry into the tank, the weight of that tank will go up by 1 ton. I don't need to relearn a lot of things we already know to be true from engineering. And the good news is that once you figure out how to do this, you can actually get away with a lot less data. So whereas in a consumer-facing business, where these techniques sort of emerged from, you need millions of hits on websites and millions of observations of customer behavior to be able to predict accurately what a customer is likely to do. In this circumstance, you can get by with a lot less. And that's good news, because in mining, we generally don't have as much data as we would like. It's only been 6 to 12 months since the sensor was recalibrated, or since we made sort of a large-scale change to the circuit. Now, the solution is a little bit more technical than my sort of hand-wavy explanation for you here. And it relies on effectively a set of maths which we call Bayesian inference. But this is really where I see the future of the application of AI in mining is going. We need to effectively rediscover what we already knew to be true from engineering. And I guess if this sounds like physics, I guess that's because it is. This is generally the direction that we'll need to head to as an industry. So I guess the good news is, or I guess the hope that I want to leave you with is that once you get this right, there is a tremendous amount of value to be unlocked. So some work we've done recently with a number of our clients is to use these models to better characterize the flotation circuits, to better characterize the equipment that extracts the metal from the ore, and then to use that to better market our products, because better fine-tune the products to the ore body in the ground. Because the products that we sell to the marketplace, we make a number of decisions that dictate the value that we will be able to extract from the ore body, principally the concentrate grade. And if we can build an accurate model of our flotation circuit, of our concentrator process, and we can layer in the economics of the various contractual terms that we have, we can then use that combined understanding of our total system to effectively align our operations with marketing. And we've seen circumstances where, when there's a significant change in the upstream, and for instance, you might be turning off an underground, or maybe opening up an underground and changing the grade substantially upstream, a change in the products that you take to market can unlock up to 4% of revenue. And this is at no cost. This is why I'm so passionate, and I love this area of technology so much, is because it's tremendously value accretive. It doesn't require a huge amount of capital. So three key takeaways that I'd like you to leave you with. The first is to maintain your skepticism. So whenever you see some results that are provided by data scientists and it doesn't look right, don't be blindsided by the AI. It's not magic. It doesn't understand causality, and generally the data sets are missing some of the key pieces of information that you need to make this stuff work. And the second is that, as an industry, for us to progress in this dimension, we really do need to get better at integrating engineering and data science. We need to train our data scientists who have learned a lot about computers and cutting code and how to train algorithms on data, about the principles of engineering, so that they have a half a chance of layering that into their algorithms. The other thing we can do is to retrain our engineers in data science techniques. Actually, as I was building the Gamma data science business at BCG, the first half a dozen or so people that I hired were engineers that we simply retrained to do things like use machine learning algorithms or design optimization algorithms to solve business problems, because a lot of the skills that you have as an engineer are immediately adjacent to those of a data scientist. And then the third is don't give up. This hasn't been an easy journey. I think there are quite some projects that have fallen foul of this issue of forgetting that correlation does not imply causality. It seems that despite that's the first thing we all learn in after 7 years and an advanced degree in machine learning and AI, we tend to forget it. But I think we've realized it by now, and I think that we all know, and we have certainly seen from a set of projects that have been successful, that there's a huge amount of value to be had here. And I think to the future generations of the planet to make the most of those ore bodies from which we are extracting the metals to move forward the human race. And I believe that analytics and AI are going to be a big part of helping us to do just that. So with that, I'll call for your attention and maybe take questions from yourself, Rohin.
Yeah, No worries. Thanks, Rowan, for your presentation. So the chat box is open, so feel free to, those online, to jump in and answer, post some questions for Rowan. So while we're waiting, they're just starting to come through now. I'll have a quick look at the live poll. So the poll question was, where do you think tech and data can deliver most value in the copper mining sector? And it's a line ball between recovery, which you've sort of addressed already, but then exploration and discovery is also rated quite highly. So can you share some preliminary thoughts and ideas on, the work that you're doing in that sort of exploration and discovery space and some possibilities there?
Yeah, I mean, I think the exploration and discovery phase is not immune from the same problem, I think. Certainly, what I've seen in this space is there are a lot of people who are trying to train convolutional neural networks to try to find ore deposits given multiple layers of data. And it all comes down to the fact that if it learns the wrong thing, it's unhelpful. So I know many data science teams that are trying to work on this project are effectively trying to train the algorithm to spot where copper deposits are based on where known copper deposits are. But how, and you can even show, in simulation that the algorithm has learnt to find copper deposits seemingly on data sets that it's never seen. But what is it learning, right? Is it learning, the geological characteristics of the terrain that are associated with the deposit, or is it learning the fact that, well, there's a mine there, and if there's likely to be infrastructure there, well, therefore there's likely to be a mine. So, we need to be very careful when we apply these algorithms that we're not, the algorithm is not cheating, right? It's not learning to find those deposits on the basis of things like, well, it's near a set of roads and there seems to be a bunch of built up infrastructure, therefore there's probably a mine there, right? Because it's not going to be particularly good at finding copper deposits of which there isn't a mine already in existence.
Yep. Yeah. Okay, that's great. Thanks. Makes perfect sense. So we jump across to the question. So we've got a question here. So you mention often that we don't have as much data as we would like. Does using short-term data sets to push the boundaries of operating capacity via digital twinning increase the risk of operational failure?
It's a good question. I guess one thing I would say is obviously safety has to come first in all things, right? Especially in this industry that we're operating in. So I think it is it's incumbent on us to, even in these projects that are seemingly separate to core operations, we should always be asking ourselves that, how are we impacting on the operation? Is that going to have some impact when it comes to safety? I guess getting to the question more specifically, the risk that I imagine the questioner is highlighting is that if you are using these tools to effectively try to push the equipment closer to the edge of its performance, then you are likely to increase the potential of failure. Now, I guess in some circumstances that has to be the case, and I suppose this is where the data scientists need to continue to work sort of hand in hand with the engineers that really understand what's the operating envelope, what is a safe sort of region in which we can operate this, whether it be by a human or whether it be by an algorithm.
Yeah. Okay. Excellent. Thank you. Just another question. What about the use of data or models from sectors outside of mining, and then taking the learnings from that sort of analysis and applying some of those outcomes and models to the mining sector? Is that something that you see more of, or are there similarities with some sectors that can shed light on the mining sector, or
yeah,
does that not really happen?
My view on this is probably not, and this is why it's harder in mining than it is in many other industries. And if you have a look at just looking at like the market capitalization of AI businesses, it's those businesses that are focusing on consumer-facing use cases that seem to be scaling much faster. And I think that's because in that space, the use cases tend to be more transferable, right? So it's generally about modeling customer propensities. It's about understanding human behavior. And whether you're doing that for a bank or whether you're doing that for a retail business, generally the concepts are similar enough. Now, how similar is a flotation circuit, refining copper, to a robot constructing a car? I think it's just an unfortunate, but a characteristic of this problem, that you really need to understand the domain very specifically when you go to apply these algorithms. And and there isn't a lot to be had from cross-learning from sort of other areas. Now, there is a lot to be had from cross-learning from other equipment, which is more or less the same. So if you're operating a bunch of SAG mills, then you should be able to use techniques which effectively you can build one model across multiple SAGs through cross-learning that would be better than any model built on one SAG alone. But it needs to be a model that's specific to that piece of kit.
Yeah, okay. Excellent, no worries. So another question's just come through. How is AI best used to support the scientific method?
Yeah, it's a good question, right? And I think because there's a lot of debate about whether or not we should probably just sort of throw out this stuff, because it does lead to a lot of nonsense conclusions, right? I mean, at its purest, any AI algorithm is really just a glorified curve fitting technique. It just helps you find correlations. So I think I'm not that extreme. I think the two can work hand in hand. I would say, the scientific method is generally around creating a hypothesis and then seeing if the data can effectively validate that or doesn't disprove that hypothesis. And as long as you continue to not disprove the hypothesis, you hold that hypothesis firm. Whereas, machine learning is more around chuck the data in and see what it says. Now, I think that there is something from using these glorified curve fitting techniques as inspiration. We'll call it maybe hypothesis seeking. So I think that there is a role for these algorithms to spot patterns and relationships and correlations that we otherwise might not see, and then spur thoughts in us around what might be causing that, which we can then feed into the scientific method. But it's not a wholesale replacement for it, I would say.
Okay.
Yeah.
Excellent. Just one final question from me. Do you think the mining industry in general is a little bit more conservative in its thinking and slower on the uptake in this AI/ML, or are there certain sectors of the mining industry that openly embrace the potential value proposition that AI and ML presents as opposed to other sectors?
Yeah, I think we are on a maturity curve, right? And we are lagging other industries. But that's probably because, in my view, it's because it's not been as important for us as an industry, right? Like, if you think about, if you're a consumer business operating on razor thin margins and you're not particularly good at protecting market share, then you live and die by this stuff. If you're a mining company, as long as you've got a tier one asset close to a port that's got high grade, you're going to make money hand over fist as long as the commodity price is high enough. So, this AI stuff is all about the last 5 to 10%. It doesn't have to be the last 5 to 10%, but I think, it certainly, if you think about, what's going to move the needle, when it comes to the TSR of a business, you probably wouldn't start with AI. But I think we are getting there now. And I think most businesses are getting there now. I think, for what I'm seeing a lot of, of really encouraging things, in fixed plant optimization, as we've just discussed, also in teams that are looking to optimize integrated operations. Because if you think about, this is fundamentally about improving the way we make decisions. And if you look at a business where is a lot of value created or destroyed from decisions, it's really in those parts of the business that do integrated operations. So I think we are, as an industry, lagging, which has some benefits because we can learn from what's come before us. But I'm certainly seeing a lot of encouraging signs. And I think this will be, we're really just getting started. I think we're going to see a lot of this play out in the next decade or so.
Yeah, excellent, awesome. Thanks you very much for that. Just one last check on the live poll, and it's still a tie between recovery and exploration and discovery. So there you go.
Okay.
Excellent. Thanks very much for your time, Rohin. Appreciate that.
Pleasure, Ron.
Excellent. So that draws. Okay. Pause there. Sorry. Thanks, mate. That was really good.
Oh, good.
Thanks to Rohin from BCG for his incredible insights into the world of AI and machine learning and the role that plays across the value chain. So that's all the questions we have for today, and that brings to an end our sessions for Copper to the World 2022. So thank you very much to all of our speakers today: Cliffy Wilson, the Minister for Energy and Mining, Tom Koutsantonis, Yi Zhu, Tim Gerard, Andrea Vicari, and of course Rohin Hood as well. So it's been an enlightening and thought-provoking few hours, and I hope, like me, that you'll log off today with some new ideas and some new conversations to be had with your colleagues that support changes to the way we operate and across organisations. So All of the presentations will be available online soon, and we'll get the questions that were posed to Andrea, and then provide those responses as well. So again, thank you very much for your time today, and we look forward to seeing you at Copper to the World 2023 with Ostmine, and thank you for attending today, and goodbye.